We are going to multiply two binomials, but first we are going to use the exponent product rule and review that because I think that's helpful for multiplying the two binomials when we get to variables. So let's first talk about the exponent product rule. If you are multiplying two variables, they have the same base, so they're both the same letter, then you're going to add the exponents together and keep the same base. So we've got a base of x and we added a plus b, the exponents. Obviously, when these are numbers, we can just combine those together and make one number. So let's do that with this examples here, a, b, and c. We've got x squared times x to the third. Double check. Do we have two different bases that are the same? Yes, then that means we can keep the same base and add the numbers. So this is going to be 2 plus 3, which is 5. So that's x to the fifth. Don't know what's going on with my pen, but we're rolling with it. All right, here, b, we've got x squared times x. My number one suggestion when we start looking at exponents is anything that you can't see an exponent for has an exponent. It is understood to be 1, but go ahead and put it down. Lots of times we don't want the 1, okay? But when we're dealing with exponents, oftentimes we need to see that. So here, this is going to be x squared, and this will be x to the first. That helps us do our addition. So this would be x, and 2 plus 1 is 3. I almost wrote that wrong. 3, okay. All right, and lastly, this is going to be what we see the most when we do multiplying two binomials in our next two problems. We have x times x. So again, these have the same variable, same base. What are our exponents here? X has to the first power. The other x is also to the first power. So when we multiply, we've got x, and 1 plus 1 is 2. So x times x is x squared. Okay, that's multiplying two variables. That's using our product rule for exponents. Let's talk about multiplying two binomials. Binomials means two terms. So you see we have two terms and two terms being multiplied together. Some of you will know this as FOIL method, although I'm not going to teach it this way. If you know FOIL method or box method or area model, there's so many ways to teach it. I'm not going to teach it that way, but feel free to use that. I'm fine with that. What I want to think about this as is we've already talked about distributive property. I want to turn this into two distributive property problems. So we have, let's say we have ax plus b and cx plus d. Okay. Our ax, the very first term, is going to go first, and we're going to multiply that by the entire second parentheses. Then we're going to do plus b, and we're going to multiply that by the entire second parentheses. So you see that second parentheses ends up getting written twice. And then the stuff in the first parentheses is what is in front here. This is really going to matter later when we start factoring. I know that's a dirty word for some people, but factoring in future units. Okay, so let's take this idea and apply it to this first problem. 2x plus 3 times 5x plus 9. We want to take the very first term and write it first. Then we're going to take 5x plus 9 and write it second. Okay, then we're going to go back to our first group and we're going to use the plus 3 this time. But we're going to use the same 5x plus 3. Sorry, 5x plus 9 again. So those 5x plus 9s are repeated, and then the stuff in the front becomes or comes from these first, or the first parentheses. All right. So basically what that helps us do is turn this into two distributive property problems. And we know how to do that. We know how to do distributive property. Now, the only major difference here is we've got x's that we're multiplying, but we just learned how to do that. So let's take all these concepts and put them together. We are going to do 2x times 5x. So you're going to multiply the numbers together. 2 times 5 is 10. Then you're going to multiply the variables together. So x to the first and x to the first is x squared, just like we talked about there with c in the previous problem. Okay, next we're going to bring down this little plus sign here. and 2x times 9. 2 times 9 is 18. But don't forget, you have an x hanging out here. Okay, so if there's an x in front, you have to give an x to every one of these terms, an extra x. Okay, so that's our first set of parentheses. Let's look at our next set. We have plus 3 times 5x. Multiply your numbers. 3 times 5 is 15. Don't forget to bring down the x. And then 3 times 9. So this is going to be plus 27. And typically when you're doing this multiplying two binomials, your first term is going to have x squared, your middle two will have x, and the last one will be a constant. And I said typically, but not always. So it just depends on the problem. This is what we're looking for though. All right. I can't continue until I add like terms. So I won't get the final answer until I add like terms. So we're going to add these here in the middle. Notice, and again, remember, what are like terms? Like terms are terms that have the same variable raised to the same power. So if you have x squared, that is not the same as just x. But if you have two x's, you can put those together. So that means we're bringing down the 10x squared, and we're going to put together 18x plus 15x. So this is going to give me 33x, and then we'll bring down the 27. Now, again, in previous videos, we were solving, but notice here we have no equal sign. So because of this, this is the answer. You are done. You're done. We like that. Okay, so nothing to solve. You were just simplifying there. Let's do the same thing for the next one. So again, setting this up, we're turning it into two distributed property problems. We're going to have the 3x come down and our second parentheses written next. And then the minus 4 comes down and our second parentheses is written again. Okay, distribute. So 3x times x, 3 times, remember there's a 1 here. So 3 times 1 is 3, and x times x is x squared. Remember, there's a 1 and a 1. Then 3x times negative 5 is negative 15x. Done with that parentheses. Let's look at our next one. Careful, we are distributing a negative here. So we have a 1 here in front. Negative 4 times 1x is negative 4. Don't forget the x. And careful here. Negative 4 times negative 5. 4 times 5 is 20, but what is my sign? What's my sign? Negative times a negative. That's going to be our positive. Okay? So that is a commonly missed problem. Be careful with your signs, especially when you distribute. We are almost done. We're going to combine these like terms here in the middle. That will give us 3x squared minus 19x plus 20. And that is our final answer for that problem.